derivative and the tangent line problem. First, we begin with the concept of the derivative and the problem that was initiated in the process of being able to calculate the tangent slope of a curve. And in this process, we understand from Isaac Newton, from Leibniz, from Isaac Barrow, from Rene Descartes, from Christian Huygens, that from the 1600s through the 1700s, this question had erupted in terms of how to be able to calculate a moving slope, a slope of a curve at various points on that curve. And if the curve shifts, then obviously the so-called the slope of the tangent would change as well. This slope of the tangent is given the name derivative, and from it we have the same concept of the velocity of a moving particle in space at a particular time. So at each time we can calculate the so-called velocity of that particle as it moves. That shift in the direction with respect to the time or the movement is said to be also the slope of the tangent. It comes from the concept of the slope of the secant, where the secant being where a line would cross a curve at 2 points. If we somehow shrink that measure, we then calculate the slope of the tangent being the line that crosses or touches a curve at only 1 point. So the definition of the tangent line with slope m is said to be if f is defined on an open interval containing c, and if the limit of the difference quotient of the difference of y with respect to the difference of x, as the difference of x, the measure of the x values, are said to diminish or to get very small, then this slope of the secant becomes the slope of the tangent. Thus, we call this the derivative. So first, we'll use this definition for the slope of the tangent or the derivative to be able to calculate here the slope of the tangent line to the graph of the function at the given point. We use the definition. So here we use the above definition to calculate the slope of the tangent. So graphically, if we look at what we're trying to get, here we have this parabola that shifts down to 9 units. This point here is the point 0, -9. Now the point x equal to 2, if x is 2, we get 4 minus 9, we get -5. So x is equal to 2 and y is equal to -5. And this tangent that we're investigating, this tangent line, is actually the line that touches this point and so this line here is said to be the slope of the tangent. Now, so that's graphically. Let us analytically find it. And so we call this slope the derivative. With our notation here is g prime of x for the so-called derivative or the slope of the tangent. So this is the limit. We say is delta x, the difference of the x values get very small. Well, we're using g here for this problem. G of x plus delta x minus g of x all over delta x. Looking at this particular problem, this is the limit as delta x goes to 0. The g of x plus delta x, basically wherever we have x, we replace that with x plus delta x. So this is x plus delta x to be squared minus 9, which takes into account this term here. So now the minus g of x, and g of x is x squared minus 9. This is all over delta x. So we get the limit as delta x goes to 0. We simplify all of this. We FOIL out x plus delta x squared. That gives us x squared plus 2x delta x plus delta x to be squared minus 9 minus x squared plus 9. Now if everything is correct, all the terms are canceled out except the terms that have a delta x in them. So this leaves us with the limit as delta x goes to 0. Now the 2x delta x plus the delta x squared, let's go ahead and factor out a delta x. And so we have left parentheses 2x plus delta x divided by delta x. Delta x here cancels out. We have left the limit as delta x goes to 0 of 2x plus delta x. Now as delta x goes to 0, we have left the limit of 2x, and 2x would be a constant in comparison to delta x. Here, this delta x there goes to 0. So now we're asked to find the slope of the tangent at the point 2, negative 5. So here x is equal to 2, y is equal to negative 5. So we find this slope, which we use the notation, the g prime or f prime, g prime at 2, because the point there was 2 comma negative 5. That's equal to 2 times x, and x here is 2. So all we have there is just 4. Secondly, we investigate the question of being able to find the derivative based on the definition of the limit. So here, find the derivative of the function by the limit process. We say that the limit of delta x, delta y over delta x, as delta x goes to 0, is called the derivative, f prime of x. And so this is basically the slope still, the difference of y with respect to the difference of x. Let's see. So f prime of x is said to be the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. This is, yes, the limit as delta x goes to 0. The f of x plus delta x simply says wherever you see x, you write in parentheses x plus delta x. So this is negative 10 times parentheses x plus delta x. Now is minus f of x. Minus here f of x is negative 10x. That's all over delta x. So this is now the limit as delta x goes to 0 of negative 10x minus 10 delta x plus 10x all over delta x. Now the minus 10x and the plus 10x will cancel. So we have f prime of x is equal to the negative 10 delta x divided by delta x. And what we have here is just negative 10. Now you know that if the function is a straight line where y is equal to mx plus b, obviously the number m associated with x is the slope, right? And so it stands to reason that if this is negative 10x plus 0, where 0 would be the y-intercept, negative 10 is the slope. And that should make sense even by the definition of the limit as well. Let's look at this one. So f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Excuse me. So this is the limit as delta x goes to 0. We're going to replace, for the f of x plus delta x, replace x with x plus delta x. This is x plus delta x to be squared plus x plus delta x minus 3, now minus f of x, minus brackets x squared plus x minus 3. And this is all over delta x. We simplify that. So f prime of x is equal to the limit as delta x goes to 0. Just FOIL this out, simplify everything else. So this is x squared plus 2x delta x plus delta x to be squared plus x plus delta x minus 3 minus x squared minus x plus 3 all over delta x. Again, if we do everything correctly, the terms without delta x will cancel for our numerator. So the x squared minus x squared goes away, x minus x, and the minus 3 plus the 3 is equal to what we have left is factor out of delta x up top. This is the limit as delta x goes to 0, delta x times 2x plus delta x all over delta x. Delta x's cancel out, and so we have left f prime of x is equal to, excuse me, f prime of x is equal to the limit as delta x goes to 0 of 2x plus delta x. Now as delta x goes to 0, we have left the limit of 2x, which in comparison to delta x, 2x would be a constant in that sense. Well, 2x definitely is changing, but with respect to delta x, it becomes a fixed point for whatever value of x that you have.